It's my great pleasure to welcome Jess Moran, who is our guest speaker tonight, talking on the rather scary subject, but not scary if we get on top of it, American foulbrood. Jess is currently a PhD student at UWA. She is also working with the Department of Primary Industry and Regional Development, working with James Sheehan in the most important agricultural industry in WA, beekeeping, and all it produces and all it's going to produce. But first we've got to protect it, and an important issue to deal with is American foulbrood. So I won't say more. I invite Jess Moran up to take the podium.
My name is Jessica Moran, although sometimes I do go by Jessica Bikaun in my science name. And in 2014, I became absolutely addicted to bees. I looked too close and I couldn't look away. Basically, I started doing some research with the old bee group, CIBER, Centre for Integrative Bee Research, and Boris Baer took me under his wing and I did my honours looking at sperm motility of honeybees, which is a fascinating subject and I could talk about it all night, but I won't. And then in 2018, I started doing my PhD on American foulbrood, and this is really my bread and butter, and what I'm here to talk to you about tonight is how to manage the disease and what to look for. But in early April, I started doing 1 day a week just at DPIRD for the bee biosecurity program, and that's really kind of why I'm here now. So before I go any further, I would like to acknowledge that this is part of the National Bee Biosecurity Program. This is funded in part by the honey levy, which the commercial beekeepers put a few cents on the dollar for every kilo into that levy, and then our program gets managed by Plant Health Australia. So without that honey levy, basically I wouldn't be able to be here. So today I'm going to be talking about 4 main areas. A little bit on the history of AFB, or American foulbrood, the essential biology. I get very excited by all of the scientific details, but I'll try not to bore you, don't worry. The signs and the symptoms that you need to be looking for in your hive, and then what you do if you actually find that disease in your hive. So the history of American foulbrood. AFB is a really old disease. Basically, we think it has been around since even Aristotle in 350 BC. Aristotle commented on finding hives that were sick and dying that smelled really bad. So we think that it has been around for that long at least. There was only a formal description of the disease in 1769. And then in the early 1900s, it actually became clear that there was 2 different foulbroods, and that's the European foulbrood and American foulbrood. We don't have European foulbrood in WA, but it doesn't hurt to keep a lookout for it either. So if you spot anything unusual that doesn't seem quite right, always give us a call. And it's gone through lots of taxonomic revisions with scientists. We like to look closer and closer and figure things out more and more. So in 2006, it got reclassified to Paenibacillus larvae is the bacteria that causes the disease, and that has a number of genotypes which vary in their virulence. So some of them kill the larvae really quickly, whereas others are a bit slower to do so. When we look at American foulbrood in WA, it was pretty widespread throughout the state by 1898. And the first outbreaks were actually discovered in apiaries near the seaports, which is pretty common for biosecurity diseases. It often comes in that way. So in the 2006 report done by Rob Manning, it was noted that it's pretty much throughout WA, as you can see on the map, and is reported everywhere by commercial and hobby beekeepers. This disease, it doesn't discriminate. So it's not just a commercial problem and it's not just a hobbyist problem. It's always something to look for if you have a beehive at all. The latest statistics that we have on AFB, because there aren't a lot of statistics, unfortunately, because people don't tend to report the disease, but what we can draw upon are survey reports. So this was the 2019 Honeybee Health Survey from Plant Health Australia. And in terms of the hives that were lost due to pests and diseases, it was seen that for commercial hives, 35% of the pest and disease causing hive loss was American foulbrood, and hobbyists reported 21%. So we know that this disease is still affecting the industry as a whole, and it's affecting both parts of the industry. And the commercial beekeepers, they're quite confident in being able to identify and diagnose the disease, which is unsurprising. But when we look at hobby beekeepers, particularly in WA, it's only about 50% of hobby beekeepers in WA are confident in being able to recognise the signs of the disease. Does this have a laser pointer? Yeah. Okay, excellent. All right. So this is a red flag for us, and it's part of why I'm here tonight. So I'm here purely to help people understand more about the disease. I'm just in an educational and outreach capacity. I'm not here to wave a big stick or anything like that. So please come and talk to me if you need help and if you want to talk about AFB further. I'm here for support. American foulbrood in Australia, it's right across Australia. It's in every state and territory. It's fatal. If you leave the hive, then it does eventually succumb to the infection. And in mainland Australia, we have a policy of not using antibiotics, and that's for good reason, which I'll get to. Every year it costs the industry millions of dollars. So really it's very important, even if you have that one hive, it's important to be considering it from a biosecurity perspective. If your hive gets the disease, that can go on to affect the rest of the industry. And you are likely to come across this disease or know someone who will come across this disease. So in 2006, there was a survey of New South Wales beekeepers, and 56% of them said that they had a history of AFB in their apiary. At some point or another, they'd had contact with AFB. And unfortunately, between 1971 and 2006, we've seen that statistic has been increasing. And this is possibly due to the increase in hive densities. We know that lots of people are getting involved in beekeeping, which is excellent, but we are keeping more and more hives closer together, often in cases where there's not a lot of resources around. Pollination is an example of this, where you bring lots of hives in and it's on the shoulder period of flowering, so they're quite nutritionally scarce, and they might do some robbing, which can spread the disease. So we know that AFB is a real problem in Australia, but this is the education and outreach is really where it's important. So for the biology, I'm going to walk you through this because I think that the biology has some really important components of it that will help you understand why you need to manage the disease in certain ways. So first, the biology as an overview, it starts when the larva is fed spores of American foulbrood. That spore goes on to, or those spores rather, go on to germinate and proliferate in the midgut of the larva. Eventually they build up in such numbers that they break through the lining of the gut and they effectively cause septicemia, basically a blood infection which kills the larvae or the prepupa at this stage. So here with the virulence of the disease, it really depends what stage the pupa larva is at. It can be an uncapped larva or it could be a capped prepupa. It then goes on to basically dissolve the brood and it turns into this horrible ropy brown mass. And this all smells bad, I should point out. And then eventually this dries down into a very spore-rich scale. And this can go on to kill the entire hive with the undersupply of brood, and then it can spread to other hives as well. And this worker cleaning out the cell would likely transmit those spores to other bees, which will then give them to more larvae. So starting from the start with the spore-forming bacteria, this is a really important part of the bacteria because it being spore-forming, this endospore means that it's long-lived. So the bacteria can actually lie in wait, being dormant for over 60 years. If you get used equipment, you want to know where that equipment came from and why that person stopped being a beekeeper. So it can survive in all hive components. They can get trapped in wax and honey, and they will be in the pollen. And the problem is that they're quite resilient to heat, cold and drying. So unfortunately, if you take off a box that's infected with AFB and you put it in the shed, you could still come back after those 50 years and those spores would be fully ready to go and infect new larvae. The important thing here is that with these tough spores, they're not affected by antibiotics. If people are using antibiotics to treat the disease, and I say treat the disease, it will only affect the vegetative cells. So these are when it's already germinated in the midgut and it's causing the actual infection, but it won't affect the spores. So antibiotics, the spores will actually just hang out in the system. Basically, as soon as you stop using the antibiotics, you're likely to have that disease come back. And this is what they're starting to see, particularly in the United States and in Canada, where for a long time they have been just treating hives prophylactically with antibiotics, and now they're bringing legislation to stop that, and they're having real issues with it. So if you hear of people talking about using antibiotics, which is not permitted here, just let them know that they will have problems later on if they continue to do so. So the larvae are fed the spores by the nurse bees. It germinates rapidly in the midgut, and they're highly infectious in the young larvae. Basically, it only takes 6 to 10 spores to cause that fatal infection in the larvae. The problem here is that it's fast spreading. So if you have one diseased cell in the hive, that can create 2.5 billion spores. So it only takes 10 spores to create another fatal infection. You can do the math quite easily, how many larvae it can affect. The brood dies eventually, and that's strain dependent. The problem is that between these two stages, that larvae is completely asymptomatic. It looks like a normal healthy larvae until it actually dies. So you could have other larvae that are diseased in the hive without them showing symptoms. So if you find one diseased larvae in a hive, you've likely got many more, you just can't tell yet. So the brood dies from septicemia at about 7 to 12 days after ingesting the spores. And this is where you start getting this coffee-coloured dead brood, and that timing really depends on the bacterial genotype. So the faster killing strains can be harder to detect. Basically what happens is that if it's killed slower, then there's more brood building up that show the symptoms, and you're likely to see that as the beekeeper. But if it's being killed faster, the worker bee comes along and sees it before it's capped and is given a chance basically to pull it out of the hive. So that can suppress the symptoms visually, and you as the beekeeper might not be able to notice it quite as fast. Eventually though, the disease does take over the hive because it's still killing this brood, you're just not seeing it. So the larvae gets liquefied and becomes this ropy mass, and I'll show you this is one of the biggest symptoms to look out for. This is where the larvae looks quite ropey, it's very gluey, it's all sticky and it smells awful. And you will see a slumped larvae, a pupal tongue, which I'll show you in a minute. And this is where you start getting a foul odour. So when you open a beehive, you want to be using all of your senses. If you open a hive and you're repelled by the smell, there's something wrong with that hive, and it definitely needs further investigation. And AFB could be one of the many things causing that smell. And the infectious scale, as I said, the larvae, it dries down into this scale that's spore-rich. And there's about 2.5, 2.6 billion spores. So even one diseased larva is a big problem for your hive. And the spores will spread and the cycle will start again. I forgot to say as well, I will make these slides available as a PDF afterwards, so don't feel like you need to take photos or take notes. Enjoy the talk. So when we think about the transmission routes that are coming out of this, we have different levels of concern with different activities. So negligible, and I'm not saying no risk, I'm just saying very low risk, not no risk. Negligible risk is where you're buying queens or the beeswax foundation. So there is some risk, but it's not a huge risk. Low to moderate risk is where you're having contaminated bee boxes, lids and bottoms moving around, and collecting swarms. And I'll come back to this again, but collecting swarms, in the 2006 survey by Rob Manning, it was shown that about 3.3% of feral colonies and hives in WA have AFB spores. So that's about a 1 in 30 chance of actually picking up AFB if you're doing that consistently. And you can have bees drifting where they're going back to the wrong colony after a hard day's work. So the worker bees themselves will be carrying the spores, but they're unaffected by the disease. It's only the brood that are really showing the symptoms and dying. High risk activities are things like feeding contaminated pollen and or honey, and where you have bees robbing. So as I said, the disease, the bacteria, they can be in the honey and the pollen. So if you're feeding something that has the disease, it will quickly spread to whatever you're feeding it to. And robbing diseased hives, they can be managed or feral. So if there's a dead colony that's feral, it possibly had AFB. So if your bees are hungry, they could be robbing potentially diseased honey. And the extreme risk is very much moving contaminated combs around. So this is your brood honey, your stickies. So that's something to keep in mind if you're getting into beekeeping, whether or not to run a barrier system. And I will talk about that later as well. So just something to keep in mind. You can think of it like COVID. You don't really want your beehives mixing too much in case of that disease transmission. So what you can see here is that the main way that it gets from A to B is actually the beekeeper using contaminated materials. The only way that it's really moving from hive to hive is mostly robbing naturally. So the beekeeper's activities are really what drives the disease transmission. So just to sum up this quickly, we've had all colonies are susceptible, especially the strong colonies, and that's because of that robbing behaviour. If you've got a really strong colony that is hungry, it could be going and preying on a weaker colony, stealing honey from it, and it might be weak because it has AFB. The spores are hardy and long-lived. One infected larvae, lots of spores, so it's already a problem if you've got one infected larvae. Antibiotics are not a good idea. No larvae symptoms for 7 to 10 days. So in this period, you really can't underestimate that infection. You have to be quite concerned if you see, again, just one infected larvae is a big problem. And the infections are primarily spread by beekeepers and robbing. So what you can see from the biology, I hope, is that the beekeeper is the primary source of transmission, and that if you've got one infected larvae, you need to intervene immediately. So let's get to the fun part, the AFB signs and symptoms. So this as a whole is what you might see if you have a hive with AFB. I'm not sure how clear this is, but the general symptoms that you might be seeing is an overall weak hive with not as much, the lower population than expected because of that undersupply of brood. You can see that this brood pattern is also very spotty. Normally you would want quite a uniform laying pattern and lots of nice white pearly brood. But here we have what's called a shotgun brood pattern where it's very patchy, and we're seeing lots of things like there's larvae in here. I'm not sure how clear this is, but there's larvae in here that are that coffee colour slumping. They're not looking happy at all. They're quite dead. And here's the pupal tongue is another symptom as well. So this is where the pre-pupa has died and it's actually left a tongue strand stuck to the cell roof there. And that's actually a symptom that's specific to AFB. The other things that you can see, hopefully, are that there's black-brown dried scales. So that's where the larvae has been dead for over a month and it's dried down. And as well, there's lots of little perforations around where the bees have been chewing on the caps, and these are off-centre. The centre holes in cappings can be where the bees are filling up or they're breaking out. But these off-centre small perforations, they can be an indication of the bees inspecting the cell and that there's something not quite right there. And there's lots of cells that are just a bit darker, they're a bit sunken and a little bit greasy looking. And although you can't see it, in this particular hive there was quite a foul odour as well. So this is a close-up of what it looks like when the brood are roping out. You might have heard of the matchstick test. This is where you take a matchstick and you insert the non-striking end into a suspect larva, and then you give it a bit of a jiggle and you pull it out slowly. If it comes out with this lovely rope, then that's a good indication of AFB. European foulbrood, which is on the east coast, will also give a rope, but it's much shorter. So AFB gives quite a long rope, and it's very smooth and elastic as well. It'll be a bit stringy and actually bounce if you jiggle it around, although I don't advise it because it's quite disgusting. In terms of the uncapped brood, what you're likely to see is these coffee-coloured, kind of caramel-coloured larvae, where as they age or after death, they get darker and darker. This is actually a pupa that's died over here. And this is what you see straight on. So that is a slumped, turning caramel-coloured larvae that has died from the disease. And here are some more of those perforations as well. And here's a nice example of it's being capped over. The larvae has died behind the capping, and that's part of why all of these cells are greasy looking and sunken, because of that extra moisture that's behind that cell, causing it to sink in on itself. So for the capped brood, again, you can see that there's very irregular pattern of the brood. It's very patchy. The caps are very sunken. Again, lots of perforations, all of those chewing, where the workers have been chewing, they're off center. Very greasy in appearance as well, and that's from, as I said, the moisture. And in cases where the hive is hygienic, I think earlier we had a question about whether hygienic behaviour is an inherited trait. AFB has been something that people have been trying to select for more hygienic bees as well. If your bees are quite hygienic, they might have pulled out the dead larvae. So they can try and suppress the symptoms that way, but unfortunately AFB wins every time. If you're trying to look for the scale, during a brood inspection, you can hold the frame by the lugs and then rotate it back and forth. And I advise using a head torch and really trying to get an eye in, just trying to see the bottom V of that cell. But again, this is a very advanced symptom. If you're having this symptom, then there should be other symptoms available in the hive to find first. So what we're likely to see in an initial infection are few infected coffee-coloured brood amongst healthy brood. So here's a nice pearly white larvae that's looking quite happy, whereas here's a dead larva that has turned that caramel colour. And so you might be looking for just one cell of brood that has gone to the disease in the hive. So this is why it's important to really be thorough in those brood inspections. And this would definitely rope out if probed with that matchstick. The matchstick is probably your best friend as a biosecurity tool. If you find anything that doesn't look quite right, stick a matchstick into it, wiggle it around, pull it out. If it comes out white and hard and a bit chalky, you've probably got chalk brood, the fungus. If it comes out in a bit of the larvae looks like it's in a sac and it's liquid in the middle but tough on the outside, it's probably sac brood virus. And if it comes out as that horrible rope, then it's a good indication of AFB. The cappings as well, you might find just a couple of caps, these ones circled here, they're obviously darker than the caps around. So they're darker, discoloured, sunken, and they look a bit greasy if you catch the light on them. So this, although it looks healthy, is actually an initial infection example. Even though we've got a nice brood pattern, good honey stores, an overall healthy hive, there's actually two indications on this whole frame that you might be dealing with AFB. And this is why it really pays to have that thorough inspection. Although I have to admit this was for my field experiment during my PhD, so I was actively looking with a fine-tooth comb. But here you can see that there's just one cell here that's got a slumped larva. Unfortunately, it's not very clear with the zooming in. And then over here, there's a tiny off-center perforation, which is an indication that there could be something. So the advanced infection, the symptoms here would be more for the whole hive being a strong odour, declining worker population as the brood starts dying off in significant numbers. You'd have over 50% of the brood might be infected by this point, and you're seeing dark sunken caps are quite common, very greasy. The infected brood are really dying out, and there's lots of scale at this point. So this is where the infection is very advanced, And this would be a big red flag, because if you're having something like this, it's likely that the bees have been coming in and robbing it from other hives. So you would really need to be thorough with checking the rest of your apiary. So here's the whole frame of that original zoomed in one. This was from a deadout, so this is where the entire hive had died. The AFB progression as well, it really depends on hive genetics and hive behaviour. So the point that I want to make here is if you get AFB and the symptoms disappear, you could still have a contaminated hive. It doesn't necessarily mean that the bacteria have all disappeared. For example, you could have a rapid and exponential growth of the number of diseased brood. So here it's just increasing consistently. You could have something that's slow to develop. All of this is real data, by the way. So these are 3 different hives that were treated with the same number of spores at the same time. So very much comparing the genetics of the hive and the hygienic behaviour. This one was slow to develop, so the bees really persisted in pulling out those diseased cells and suppressing that infection for as long as they could until there just wasn't enough brood to be able to do that. And here, this is where something happened where the bees, they were overcome for a little while, and then they must have gotten a second wind. They were able to suppress the disease for a few weeks, but then it really kicked up again. So if you have symptoms that disappear, don't feel calm. It can still come back. The honey stores can very much be a reservoir for these spores. So if you consider the honey store, then your hive could still very much be contaminated at this point, and you really want to make sure that you're not spreading that contamination further by moving hive components around. So I won't go through this. Again, this will all be made as a PDF, but there's a number of symptoms that are very textbook for AFB that you can look for, and there's heaps of this online. There's some excellent information and more example pictures. If you do find AFB, I would suggest taking lots of pictures of it and even inviting people to have a look, because the more confident you are with identifying the disease, the faster you are to spot it in your own hive. But again, the symptoms can appear and disappear, but the contamination is likely ongoing. And this is one of the main reasons why we need to have these regular brood inspections. So by the code of practice, we are required to check the hives at least twice per year, but ideally you want to be checking a lot more. Managing an AFB outbreak. We have kind of 2 main resources that for the national program I would like to push that you go and have a look at. There's the Biosecurity Code of Practice and the Biosecurity Manual for Beekeepers. So these are both available on the Be Aware website. You can go to beaware.org.au/biosecurity. This is an Australian website and it's managed by Plant Health Australia. So if you've been Googling things relentlessly, you might have come across a lot of materials that are aimed at New Zealand beekeepers or American beekeepers, but keep in mind that their beekeeping systems are very different because we have very different diseases. So for example, we don't have varroa, so there's lots of hive management things that we don't need to think about in terms of varroa, but they do. So definitely have a look at the Be Aware. But in terms of steps of managing an outbreak, the first step should be to report the outbreak. AFB is a notifiable disease, and under the code, an apiary inspector should be notified within 48 hours of you suspecting AFB. So these are the ways that you can report it to DPIRD. There's this email address, pbhoney@agric.wa.gov.au, or you can call the Pest and Disease Information and Service line. I'm very deliberate in not giving a specific person to call because sometimes people go on holidays. So it's always good to have a general number or a general email to send an alert to, and then someone will definitely see it. Step number 2, though, is to contain the outbreak. So again, under the code, we are required to destroy all of the bees in the hive. And this is waiting for those bees to come back to the hive and then killing that hive. And we have to also ensure that the hives and appliances that are contaminated are bee-proof until they can be cleaned and sterilised. or destroyed if necessary. So this is where you're sealing them in plastic bags and the bees can't get to them, because if bees can get to them, then they could be robbing any honey or materials off them and spreading that infection further. Ideally, this would be done immediately, but if it's not feasible to act immediately, then by the code, you're required to do it within 7 days if the hive isn't in danger of being robbed. Again, if it's in danger of being robbed, then you really need to act fast in order to not only protect your own apiary, but also to protect nearby apiaries and not get blamed by your neighbours. So in terms of destroying the bees and the brood, it's a euthanize, burn, bury method. Basically, you want to be sealing the hive at night and adding an insecticide. A lot of commercial beekeepers will use things like petrol or diesel to kill the colony. And then you'll need to dig a pit at least 30 centimetres deep. And this is important because once you've burned all of the honey, dead bees, all of the contents of that brood chamber, you'll need to cover it with soil. Again, this is to make sure that just in case there's anything that the bees might be sniffing around, they can't actually get to it. You want to make sure that this is completely sealed and out of their reach. Please do not dispose of this through the bin. There have been cases of really horrible AFB outbreaks where someone has gotten AFB, their hive has died, and they've thrown it in the wheelie bin or taken it to the tip. And then everybody that's within foraging distance of that tip has then found that their hives have come down with AFB. So please make sure that you dispose of anything properly. So the other 100% effective method of decontamination is gamma irradiation. Now, unfortunately, Stereotech, they are based on the East Coast. So although it's 100% effective and it gets rid of the bacteria DNA, it's not that accessible for us. And I'm not sure if there's many beekeepers here that aren't operating on a really commercial scale that actually engage with this service just because of the cost of freight. And unfortunately as well, gamma irradiation, from what I've read, it seems to be incompatible with plastic. This is more for people that are running timber boxes. But if we eventually get a gamma irradiation plant here in WA, or if freight becomes really cheap, then it's definitely something you can look into to salvage any of those hive materials. So you need to get rid of the bees and the brood, but you might be able to salvage, say, the top box. The other 90 to 100% effective decontamination, so obviously not as good as burning or gamma irradiation, is paraffin wax dipping. This can be achieved through 160-degree wax, dipping the boxes in for 10 minutes. And it's really important that you have it for both of those variables because there is a relationship between the temperature and the time that the boxes are in that wax and how effective it is at killing those spores. So this is the spore viability. If you're only putting it in 80-degree wax for just a second, then it's still 100% viable. And that's all the way up to 150 degrees for 4 minutes. So it's really important to be being precise about this. This can be a bit of a tricky method though, because paraffin wax does have a flash point of about 200. So it can be a bit more difficult. And I'll be honest, generally I advise that you should probably consider just burning the colony. It's better to be safe than sorry where possible. And a lot of these methods can be quite fiddly. In terms of decontaminating your hive tool, the 80% effective decontamination, it's not a bad idea to carry around a small container with bleach. So you can have sodium hypochlorite, which is the active ingredient in household bleach. You can buy things like this from Bunnings. It's about 0.5% concentration will kill AFB spores in 20 minutes. Again, the concentration and the time is important. So 1 to 3% is actually the concentration that's recommended. But the important thing to see here is that it only kills spores that it comes into contact with. So you really need to be making sure that you've cleaned off any of the wax and debris from the hive tool or whatever you're decontaminating before you start bleaching it. The other methods that are about 80% effective are dry heat and scorching. So for scorching, you might see some beekeepers have propane or blowtorches, and you can actually blowtorch the hive tool. I wouldn't recommend a smoker. Generally, we try to have a nice cool smoke so the smoke smoker isn't really hot enough to be able to kill off the spores. These are incredibly robust spores, so a blowtorch is definitely favourable. But dry heat, again, with that temperature and time relationship, it's important to have at least 130 degrees Celsius for 30 minutes or more. And if you're doing this in your oven, then I'd highly recommend an oven thermometer. I don't know if any of you are avid bakers, but I myself bake bread, and I've found that ovens can be incredibly variable in what they say their temperature is versus what their temperature actually is. But if you're moving between different apiaries, or if you're going to visit your friend who also has bees and you want to take your hive tool, you could always bake them some honey muffins and just put your hive tool in the oven at the same time, as long as it's in there for 30 minutes. So the step 3 in managing an AFB outbreak, though, is to review your beekeeping practices. And this is really important. Talk to your beekeeper friends, get advice, learn from your mistakes and learn from their mistakes as well. And make sure to just be open and honest about it. There has been this long-running stigma around AFB where people have been trying to avoid talking about it. They might not want to report it. It sometimes gets called the clap of beekeeping. So if we can remove this stigma and be more open and honest about when people have it, when people find it, it'll do us a world of good, because people, if you're sharing that your hive has it, they can go and inspect their hives for it. It's all about awareness. But the main thing here is to actually consider how it got into your apiary and what steps you can take to avoid another outbreak. So you can review your beekeeping practices. Think about, can you identify disease and are you inspecting regularly enough? So you can always go to beaware.org.au/training. And then this again is that Australian website with all of the details on our biosecurity code of practice. You can actually go to this link, and then over here, there is a link to the biosecurity online training course. So that is free for beekeepers to do, highly recommend it, and that is industry endorsed. But there's also a few tabs here that are very much of interest. There's the biosecurity and pests tabs, which again have those resources that I talked about before with the code and the biosecurity manual, but also lots of pictures and videos, examples of finding the disease, particularly in Australian hives where they're endemic pests. So have a look, particularly the videos. That's a lot from New South Wales Department of Primary Industries, and they're excellent for education. Again, reviewing your beekeeping practices. Have you recently purchased used beekeeping equipment? We know that AFB spores can be dormant for over 50 years. So if you're buying used equipment, it's important to think about the disease history of that equipment. Think about why that person got out of beekeeping and where these materials came from. So I would always recommend to buy new where possible, just to eliminate that risk. But if you are buying used equipment, buy from reputable sources. And I'm sure that there would be people here that you can talk to about who's a reputable source and maybe who to avoid. Always ask questions. Never feel guilty asking questions about bees. People love to talk about bees. If they don't want to talk about bees or beekeeping equipment and they're trying to sell you beekeeping equipment, run away. If in doubt, you can always sterilize the equipment. If you're buying hive tools, you can try to use a combination of the methods that I've given in here. So even though some methods are 80% effective, if you use a combination, then you should be pretty confident that that hive tool is then decontaminated. And if you're using boxes, if you're buying a large number of them, if you are upscaling, starting to become semi-commercial or thinking about becoming commercial and you're buying quickly, then you could always think about the freight charges for sending over east. But the main thing I want to really drill in, only buy local. So WA, this is our nice clean and green area for beekeeping. The coloured zones are actually the main beekeeping areas in Australia. WA, we only circulate beekeeping equipment that's used in this area. The Kimberley has a small hive beetle, so we don't actually allow bees or used bee equipment to move from the Kimberley down to the southwest. And similarly, the East Coast has European foulbrood, which is another bacterial disease which we don't have, and it's the main reason that our border was actually closed in the 70s. So again, we can move bees and used material out of WA, out of the southwest, but you should only be buying used equipment from this area. And again, if you're wondering about who to talk to about buying equipment, there are so many people here that would be more than happy to tell you where to go and who to talk to. So don't be afraid of asking questions. You could also think about whether you're using a barrier management system and how effective it is, or whether you'd like to start using a barrier management system. Barrier systems won't stop you from ever getting AFB, but if AFB does enter your system, then it's unlikely to spread further than that barrier. So in a barrier system, the apiary is divided into different subunits. And when I say apiary, you could be dealing with 3 hives, or you could be dealing with many, many more hives. This is all very scalable. The apiary is divided into subunits. So here I've just coloured them. And then everything goes back to where it came from. So if I took frames out of this yellow box to extract honey, those yellow frames would go back into this yellow box. They wouldn't move into the blue or the red zone. And this is all scalable. So scale it to your size of your operation or what's manageable for you. You could be running it on a pallet, and some commercial beekeepers even run it on loads, but the single hive system is most effective. The smaller your barrier unit, the less likely that disease is to spread. Because again, the main way that the disease spreads from hive to hive is actually through the beekeeper moving material around. So if you're only moving material within this hive, in theory, it shouldn't be able to move to the other hives without a serious amount of robbing going on. And the main thing to note here is that everything is cleaned as well between moving from units. So if you're working on the yellow hive and then you decide to move on to the blue hive, you might want to flame down your hive tool and make sure that everything is nice and clean and sterile before you move on. I should note as well that there are commercial beekeepers with lots of hives that are able to maintain a single hive barrier management system. So it is possible at whatever scale you're working at to still work in this single hive system. Just because you're getting more hives doesn't necessarily mean that you need to increase the size of your barriers. But again, it's all about what's manageable for you. If it simply isn't manageable to be able to do a single hive system, then you just need to work out what is, because an effective barrier management system is where you have barriers, not where you really want to have barriers but you can't quite get there, so you decide it's all too hard. Just do whatever works for you. The other thing that you can do as well is if you decide that you really do actually need to move some brood from the blue box to the yellow box, then keep detailed records when things do slip over from barrier to barrier. And then if you do find that there's an outbreak over here, you could check your records and then decide that you really need to check that hive as well. Ideally, you should be checking your entire apiary if something like this pops up, but it's really good to have those records to be able to trace it back and be able to intervene. So is your beekeeping operation clean? Another practice to think about. So beekeeping suits and gloves, they can get dirty and they can eventually become a biosecurity hazard as well. Definitely try to clean your hive tool between the units to keep it nice and sterile. But the other thing is thinking about apiary visitor etiquette. So if you're going to visit your mate, make sure you clean yourself up. Clean your tools, clean your gloves. You can also just avoid doing the whole BYO. Ask them if they've got a tool that you can borrow rather than you bring your own equipment. Ask them if they might have some just latex gloves or even some dishwashing gloves as well. That's another method that you can have to really keep everything nice and clean and sterile. But just as a rule, if you're visiting someone else's apiary, treat them the way that you would want to be treated. Make sure that you're not bringing dirty equipment into the system. And as I said before, hungry bees spread disease. We want our bees nice and fat and healthy. Strong hives will eventually rob from weaker hives if there is a dearth. If they're not getting enough resources, they will go and pick on the little guy. And the little guy could be little because he's diseased, That's the big problem here. So healthy, well-fed hives are also less susceptible at picking up other pests and diseases as well. A lot of people come and say that they've lost hives to wax moth. Often wax moth can actually be attributed to nutrition. So if you're finding that your hive is coming down to pests, or it's succumbing to pests and diseases that other people aren't having a problem with, consider your beekeeping management practices and make sure that you're not accidentally starving your hive or weakening it in some other way. So here, don't over-harvest the honey. Make sure the bees have adequate supplies. Do feed sugar when needed. It's not a bad thing to do. It's worse to have hungry bees. And don't let bees rob honey. One of the worst things that I've seen is when people will extract honey and then put the sticky frames out just for the bees to clean up. That is a big biosecurity no-no. Any bee could come and take honey from that sticky frame. So if you accidentally get AFB into the system and you don't know it, you could be then infecting so many other hives just by letting bees rob stickies. And are you catching swarms? This is another thing to keep in mind. So at the beginning, I mentioned that 3.3% of feral colonies and swarms in WA had AFB in the 2006 survey. That means that 1 in 30 feral colonies are likely to have AFB. If you are regularly catching swarms, consider putting a barrier system in place where you're quarantining those colonies moving around. So disease colonies, they might try to abandon the infection or the diseased larvae. They could try to fly away and start a new colony. Unfortunately, the workers do carry the spores, so they can start a new colony. You might catch that swarm, but then that infection will come through again because the workers still have spores in their own system. So again, consider keeping new colonies isolated and monitoring them for AFB. And something else to consider is how old are your brood combs? So brood combs can be a nice little reservoir for bacteria, fungi, pesticides, and heavy metals. So I found this at beeculture.com. This is a lovely illustration of how the combs, they get built up over time, and it's a bit like looking at tree rings. There's lots of layers here of every time that the bees have laid down new comb. Eventually, that can actually build up quite a lot of bacteria in there. So there have been studies on this, and there are less bacteria found on young combs that are 1 to 3 years old. A lot of the Scandinavian countries have a practice of changing out the combs every year, but here we suggest 3 years is a good number to try and move those combs through. And you don't have to do it all at once. You can just mark the combs and then start changing some of them over slowly when they're starting to get a bit dark and horrible. But the other benefits of doing this is, again, there have been studies. When you're using new combs, they tend to be a bit bigger in the cell size, and this leads to increase in worker population and honey production compared to when people are running really old combs. So there are lots of benefits for doing this, not just the spore loads. So to sum up here, step 1, report the outbreak to DPIRD, either through the email or calling the Pest and Disease Hotline. Contain the infection by euthanizing, burning, burying the colony, bee-proof and decontaminate the equipment, and then review your beekeeping practices. Definitely have a good talk about local beekeepers, talk to them, talk to your friends, tell them your experiences and share what you can. So, Rob McCrill was generous enough to provide a couple of the American foulbrood test kits. These work a little bit like a pregnancy test, where basically you find a suspect cell and then you put it into, there's a little jar inside and you shake it all up and then you can put a sample on the stick, and like a pregnancy test, it'll give you a couple of lines if you're in trouble. If you can spot any of these symptoms, I can give you one of these tests just to hold on to. So this is the picture from before, so even if you just want to name one of the symptoms that you remember, feel free. I've got 2 of these tests that I'm happy to give away. Very nice. Excellent. Yes, excellent job. So again, we can see that there's the perforations. This one in particular looks quite suspect. We can see that there's this pupal tongue here where the larvae has died and its little tongue is stuck to the top. We've got those coffee-coloured larvae and there is some scale around. The other ones were the weak hive, foul smell, the scale, and the shotgun pattern brood. Excellent job. So that's it from me. Again, reporting American foulbrood outbreaks through these numbers, and for more biosecurity information, always feel free to visit the DPIRD or the AGRIC, I should say, website, a hangover from when we were agriculture and food, and the beaware.org.au is also an excellent resource. And you're also very welcome to come and chat to me. But I'll take questions if there's any.
To sterilise your hive equipment, your metal equipment, can you just boil it like people do for hospitals?
You can boil it, but it's very dependent on the timing and making sure that it's consistently boiling for that amount of time. So I would recommend doing something where you don't have to think so hard about monitoring and making sure that the water level's right and all of that. I would encourage going more through the scorching method or the dry heat method in that case. Never hurts to take your neighbour some honey muffins when you're disinfecting the hive tool.
Jess, is methylated spirits any good for hive tools and so on?
Not that I'm aware of. So this bacteria, it's so incredibly robust. I think that it's always better to be safe than sorry. There are a couple of methods that you see on blogs and the internet. People try all sorts of things and they might have success with it, but it's always a numbers game. So I've only given the 100% decontamination methods or down to the 80%. Anything below that, I haven't heard of the people using methylated spirits, but these are the tried and tested.
For people who've got like small properties, etc., like in city, is there a facility that you can actually dispose of your hives at? Because we can't burn it in the backyard or anything like that.
That's a really great question, and it's something that I've been trying to find out more about through the department. I'm not aware of anything like that at the moment, but it is something that's becoming concerning with all of the backyard beekeepers. How do people dispose of this stuff feasibly? So that's something that I'm investigating. You're welcome to give me your email address and I will chase that up. But otherwise, is there any capacity for WAAS to consider some kind of annual burn-off?
It's not something we've done and possibly not something we'd pick up. I think we'd look to DPIRD to be involved and take the lead there.
Yep, no worries.
If you've extracted honey from a hive and later find that there are AFB spores, what do you do with the honey? It's still suitable for human consumption?
Yeah, you can still definitely eat the honey, but if you do find that's the case, make sure to clean all of your extraction equipment. Clean it really well, because again, as much as we need to try to bee-proof things, if you do manage to end up with bees in your extraction equipment, robbing honey from it, that's a huge biosecurity concern. So it's totally fine for human consumption. Obviously make sure that you're not feeding it to bees, but that's the main thing to remember.
Okay, and a question down the front here.
Can it be treated with low temperatures?
It doesn't seem to be. I showed that picture before of the temperature gradient. Maybe if you're right on the border of where it's starting to get that cutoff, then you might be able to do 120 degrees for a really prolonged period of time for that particular method, but you really need to be hitting those temperatures. Otherwise, that bacteria is just so robust. Okay,
So are you saying when I put my hive tools in the dishwasher to get them nice and clean, it's probably not doing it?
Probably not.
Okay.
So it's definitely something to consider. Boiling water for enough time is likely to work, but it's hard to tell what temperature your dishwasher's getting up to.
Yeah. Okay. Do we have any other questions? Okay, well, I'd like to thank Jessie. Jess, I think learning that a matchstick could be one of your most essential tools is certainly interesting, and I'll chuck some in. It's also great, as you said, to start this conversation, because it's essential that we don't just boast about our successes, but that amongst us we're prepared to say, look, we've got an issue and now get help, and to acknowledge that these things can happen. And I guess the fact that it happens to commercial beekeepers who are doing this all the time is a sign that it can happen to the best of us, so there shouldn't be shame, but we've got to talk about it. And to thank you, I'd just like to give you a little token and to also just show our appreciation for all the information you provided.
Thank you.